In part 1 we have discussed question 1 to 8, and today we are going to discuss question 9 to question 20, and the paper is October-November 2019, paper 1-1. The question is, a skydiver falls from an aircraft that is moving horizontally. The vertical component of the velocity of the skydiver is v. The vertical component of the acceleration is a. Which row describe v and during the first few seconds after the skydiver leave the aircraft? So when that one leave the aircraft, so basically this is terminal velocity topic. So when that one leave at the start, only the weight acts on that one and there is no other force. So the resultant force is basically due to the weight, because at the start the velocity is 0. As the object goes down, so then the v increases in that one. When v increases, so the drag force increases in that one. So when the drag force increase, so after few seconds the situation is like this. The weight is still w, and now the another force come, that one is drag force, and this is weight, so the resultant force become smaller because now the resultant force is F minus Ft drag force. So when the resultant force decrease, according to the equation F equal ma, when the force decrease, so the acceleration decrease. So our correct answer for this one is the v value increasing as the object is going down while the acceleration decreasing. Question number 10. Two gliders are traveling towards each other on horizontal air track. The glider P has a mass 0.30 and is moving with constant speed of 1.2 meter per second. Glider Q has a mass of this one. Value is given. The velocity of this one is this. The speed of this one is this. And the mass of P is 0.30. Data is given to us. So this question we can simplify it with two ways. If I can give you the concept of relative speed of approach is equal to the relative speed of separation, standard equation we can suppose consider for this one. If this is mass m1, velocity u1, and this is m2, u2 traveling towards right. After collisions, still they are going this way, v1, and this become v2. And in both these two, you can say that the situations I am considering, the direction of the velocity is to the right. As we know that if u1 is greater than u2, so then they can collide. And after collisions, the v1 is smaller than v2, so we can say v2 is greater than v1. So keep it in mind whenever you are writing the equation. So this is the short way for this. You can write the bigger velocity before is equal to bigger velocity after. Smaller velocity after. u1 minus u2, bigger minus smaller, is equal to greater minus smaller, in that here. So this is your standard equations for relative speed of approach equal relative speed of separation. Now if suppose in our situation here they both collide, but this one is going toward this side. If suppose I am considering this is u1, this is u2, so if I make the change in this equation, so this become u1 minus u2 equal after collision. So this one is going this way while this one is moving toward this side. So it's mean that the v, you can say the v2 is positive for the right one, and after collision I am considering this is v2 and this is v1, so then that equal minus v1. So this is our equation. So it's mean we can write it as v2 plus v1 here, and this become u1 plus u2. So this is your equations for this particular question here. If you can see, u1 is 1.2 plus 1.8, that comes 3 meter per second, the combined one. And after, you can see, you are going to choose the answer where you are going to get sum of those, and you are going to get 3 sum of those. So if you are going for the C, so 2.8 plus 0.2, so you are going to get 3 meter per second. So that's why our correct answer is C. This is one method one. The second method is you can use the kinetic energy before collision is equal to the kinetic energy after collision, m1 v1 square plus half m2 v2 square. Keep it in mind, for kinetic energy scalar, so we are not going to change any sign, so always you need to consider positive. Momentum is a vector, that's why we are changing the sign in that. And for the right, we are considering positive, left we are considering negative. So if you can find, if suppose this data is given to you here, and if you can plug the numbers, you can get 1.9, I think, that equal. Now you can try the C value for this. Suppose v1 is 2.8, v2 is 0.2, so then only that answer will give you the correct answer. So this is because perfectly elastic collisions, so kinetic energy before equal kinetic energy after collision. So it's up to you if you are using the method 2 or if you are using the method 1. Both the methods are fine for this. If still any question, you can send me that. Now the next question is question 11. Question 11 is, they said here that an object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter is Q. So here we are going to read Q, here we are going to read P in case of water. And keep it in mind that the Newton meter gives us the upthrust force. So it's mean in liquid, the weight is acting down and the upthrust force is acting up. So Q is your upthrust force, and here P is your upthrust force on that one. So if we are going to write the equations for the resultant force, so we can say that the upthrust force, uh, we can write it as, in this situation, because the object is going in the direction of the immersed in water oil, so it's mean W minus Q for this one and W minus P for that one here. Now the mass of water displaced in this one, and we know that the mass equal or I can, if I can multiply mass time G equal W minus P. Similarly, if I'm going to use mass time G equal W minus Q. And we know that the mass is basically the, if we can see that the mass equal density time volume. So we can write it as the rho density of oil time the volume of oil in that container time G equal W minus Q. And here if we are going to write the density of water time V volume time G is equal to W minus P. So this is given to us since the volume is same, the blocks are same, so same block, so it's mean that the volume is same. Volume of water is equal to volume of oil, sorry, and that equal the, and the third thing is the volume of block, that also be same. Now we are going to find the ratio of the density of oil to the density of water, and the density of oil time the volume of block time G is equal to density of water time the volume of water time G is equal to, you can find, W minus Q divide W minus P. So it's mean that our answer is, if we can see, the D is the correct answer. Just take the ratio of density of oil to the density of water, and the volume is same. Just take the ratio and simplify that and you get the answer for this. Now the next question is, which diagram shows a couple? Couple has three conditions. The first condition is the forces should be equal in magnitude. The second condition is opposite in direction. And the third one is perpendicular distance apart from each other. Now we are going to check that which diagram fulfill these three conditions for couple of forces. So first one, forces equal in magnitude, opposite in direction, perpendicular distance apart from each other. So A is correct. B is wrong. Forces are equal but not opposite. So it means the second condition is not fulfilled in this, so that's why the B is not, and this is not perpendicular in that one. Equal in magnitude, opposite in direction, so this is not opposite. This one makes certain angle, and here we have only single force, so that's not possible. So the correct answer is A. Now we are moving towards question number 13. Question number 13 is about, they said that an object of weight 120 Newton is supported in equilibrium. So the word is equilibrium by two string as shown. What is the tension T1? We are going to find this tension T1 in that, and suppose we are considering this tension is T2. Now first we are going to resolve the component of this one. If we can see, this is our T1 cosine 70, this is T1 sine 70, and on this side if we can complete this diagram, so this one is our T2 sine 20, this one is T2 cosine 20 for that one. So the horizontal components, if you can see here, our values for, as this is an equilibrium, so it's mean for x-axis we can say T1 cosine 70 is equal to T2 cosine 20 degree in that, and from this we can get the answer. After simplifying, we get T2 equal 0.364 into T1. This is my equation 1. Now vertical forces, there are three vertical forces. One is the weight, that is downward. The two forces are up. One is your this, one is your this. So we can say that for vertical one, vertical forces are T1 sine 70 plus T2 sine 20 equal 120 weight. Now we have the value of T2. We can plug the value of T2 from the equation 1. So we can get T1 sine 70 plus 0.364 T1 sine 20 is equal to 120. Then you can simplify it and we get T1 equal 113 Newton. So the C answer is correct for this. Next question is question number 14. So for question number 14, we are data is given in a large container in oil refinery. Three oils are oils of different densities. We have three different types of oils are mixed. No chemical activity occurs. The mixture consists of the information is given to us for oil 1, 2, and 3. What is the density of the mixture? So for this kind of question, first we are going to find the volume for the first one. V1 equal, you can see the M1 over the density of first one. Then V2 equal M2 over the density of second, and V3 equal M3 over the density of third oil in that. After plugging the numbers here, we get 1.09, and in the second situation we are going to get 1.74, and the third situation we are going to get 4. You can say 40. So these are our volumes and meter cube. And what is the density of the mixture and total density now we are going to find. So the total density equal total mass over total volume. So the total mass is sum of all these masses that you can sum up, and the values come 6700. Divide sum of these volumes here, that almost comes 7.23, I think. So 7.23, and you are going to get the density. That one is 927, or A answer is correct for this. So first you find the total volume, then the total mass sum up, and you get the answer. Question number 15. Question number 15 is electric motor. Motor, always whenever the motor comes, the motor converts from electrical energy to mechanical energy, and generator converts mechanical to electrical. 120 watt power is given to us of a useful mechanical output power. So this is our power output, 120 watt. The efficiency of the motor is given to us, that is 60%. Which row is correct? If you can see, our formula is efficiency equal useful energy output over total energy input. So 60% equal useful output is 120, and the total input is power input is, you can find. After this input power comes, after simplifying this one, input power comes, and that one is 200 watt. Now it's mean that the answer C and D both are, for time being we can consider C and D. Now when we have the input basically equal to the output power plus the waste power in that one. So we are going to find, now we are going to find the waste. So waste power equal your input 200 minus the output is 120, we get 80. So it's mean that the input is 200 and the output and the waste heat power output is 80. So our correct answer is D. Next question is question number 16. A fixed amount of gas undergoes series of changes to its pressure and volume, and two of the changes no work is done by or on the gas and one change work is done by the gas on its surrounding and another change work is done on the gas by its surrounding. During the change, when work is done on the gas by its surrounding, how much work is done on the gas? So keep it in mind, there are two situations: work done by the gas, we are considering in physics negative; work done on the gas, we are considering positive. Work done by the gas, suppose you have one cylinder, this is your piston here, suppose you are giving heat to this one, and due to that heat this one is going to be, you can say that the piston goes to this position, the volume increase. So this is work done by the gas. So it's mean if we can see from this point to this point, this is work done by the gas. Due to gas, the expansion comes in that one. And if you can see the from here to here, this is our work done on the gas. So on the gas, during that time the volume decrease. Suppose you are keeping on ice, heat is going out. So then, and there is no work done here and here because the volume doesn't change. So it's mean that basically we are going to find this work done in this question. Work done on the gas. If they said work done by the gas, so then we are going to find this value here. So on the gas, so our value of volume changes from here to here, and that is given to us. We can find the value, and the pressure we can see that one is around 1, so we can plug the values as we know that the work equal pressure time the change in volume. The pressure is 1.0 10 power 5 into change in volume is you can say 5 minus 2 10 power minus 4, and we get 30 joule. So our correct answer is C.